Hi, my name is Brian Robertson, and I'm just going to talk about my senior project for a while here. My project was to create a basic bootloader and kernel that will accept simple text input and have display capability as well. So this is what my project looks like, and I know it doesn't look like much, and it can't really do much at the moment as well, but it will serve as an excellent starting off point as I further develop its capabilities. I just wanted to give you an idea of what it has taken to get to this point. First, if I wanted true control over the boot process, I would need my own bootloader. In the future, I plan on developing a new file system and file formats, and having my own bootloader to boot into my own custom kernel and OS is the best way to make that possible. Because I made my own bootloader, I had to set up a lot of low-level things to prepare my kernel to take over so I could use the actual hardware of the computer and the memory. I had to set up the A20 address line, which allows me to access more than 1 megabyte of memory. Next, I had to create a GDT, or Global Descriptor Table, which essentially refers to a specific section or multiple sections of memory, and it tells the computer how to handle it, what it can and can't do with that memory, how it'll be used. Basically, I just have a really simple code segment GDT and a really simple data segment GDT. So that when I actually boot into my kernel, it knows what to do with the data and it knows what to do with the code and how to use those. Then I had to leave 16-bit real mode, which is the default mode when you boot into the BIOS, or when you use the BIOS to boot, you're in 16-bit real mode, so you can access some of the tools from the BIOS, which comes in handy. But if you want to have the memory protections that come with 32-bit protected mode, if you want to be able to access the full 32-bit memory space, you have to switch over to 32-bit. And while it's not strictly necessary for this project, in the future, I will definitely want these features afforded to me by switching to the 32-bit protected mode. At that point, from my bootloader, I could finally load the actual kernel code into memory and then jump to that address, which is the real starting point of the OS, what you currently see on the screen. And once in the kernel, what I'm doing right now is I'm just pulling the keyboard to get key presses, and I'm using the VGA memory space to display them on the screen. So now you know what's going on behind the scenes, and thanks for watching.